What's up guys? So for today's demo I'm going to be using this STM-F4 Discovery, and it is plugged into a STM-F4 Discovery Shield from MicroE. I'll give you links in the description below. And what's nice about this shield is that it has UART and a CAN bus transceiver on it. So I love this board. So let's get started with the project. Alright, first thing you want to do is open up your browser and navigate to the GitHub and go to my repository and download or clone the Timer Callback debounce, or you can just go ahead and just download the zip and save it to a folder on your computer. And the next thing you want to do is open up STM32 Cube IDE, and we're going to import the project. So we got import here, or we can do a file import, and we're going to do existing projects into workspace and click next. And I already had selected it, so it shows up, but otherwise you just browse to where you had saved the project, and then you should have this here and make sure it's checked, and then just click finish. Alright, so what we want to do is go to core here and go to include, and then open up the polling routine right here, and just want to make sure that these defines are uncommented and the rest are commented out. So this will be the first example. Alright, so I have no debounce defined. So this example will show you what happens if you don't debounce a button. And before I get into it, let's go to this LED control. In here I have 5 functions. 3 of them are blink amber LED, and it basically just toggles the pin every time I call blink amber LED. Same goes for green and blue. And as for the red LED, I control it directly, so I either set it or I clear it. So that's for that. Polling routine. Oh, before we go there, so when you start the project, you have it generate the code. Typically you'll have something like this. I went ahead and added my polling init and polling routine here, and that calls these 2 functions here. So this polling init, so I initialize things in here, and then polling routine is the main while loop. So this just right here, timer callback check, this thing just loops, and it's always checking. So let's see. And another thing is this STM32F4 XX underscore IT, the interrupt. I had to add an extern for the timer callback structure, timer callback, and you'll see that here. So this is the extern that I had copied right here. And then what I added was in the system tick a call to timer callback tick, and I'm passing the instance of the timer callback, and this timer callback is this external variable, which happens to be this variable. And I already defined this, but you can actually define your own timer callback structure, but I already had made one here. So again, I'm pulling init right before it gets to the while loop. This only gets called once, and then initialize everything, and then polling routine, this is the while loop, and this just keeps looping, and here it is, it just keeps looping here. So it's always checking timer callback check function. And you can have other tasks in here, send UART messages, check I2C devices, whatever. So this just keeps looping. So right now I have timer callback check only. So let's see. So was this no debounce. So here I registered the blink green LED, blink amber LED, and blink blue LED, and I'm passing the instance of the timer callback to this. And this is only registers these functions. It doesn't start any timers at all yet. And then this button example, I have a debounce push button, so I define that also. And then here I have blink green LED and blink amber LED. So I start a callback timer start, and I'm telling this timer callback to call this blink green LED every 500 milliseconds. So it calls this. So the first time it calls it, when you toggle, it'll toggle the LED on, and then when it repeats, I have right here timer repeat, it's going to toggle it off. So it just pretty much just blinks the LED. And then here, this is at 100 milliseconds, so the amber LED will blink a lot faster than the green. And then here I run some example. Let's see, I think that's off because I'm only doing the button. So all the example here is off right now. And so let's see. Oh, and then in the button counter here, this is the GPIO interrupt. It's the callback. So the HAL driver will call this whenever there's a push button pressed or released. And I just check to see if it was the push button, because you can have other interrupts on a different pin, and that could be named something different. I just kind of defined this here. So B1 is actually defined by the STM32Cube IDE. So it defined it as a B1 pin. So I just kind of renamed it because B1 pin just doesn't really tell you anything. So I renamed it to push button pin. And so I just make sure when you get this interrupt, it's going to pass what pin it was, and I just make sure it was a push button. And then I still have to read the button state, whether it's on or off. So that's what I'm checking here. So the button state, if it's set, that means the push button was pushed. And I do a callback timer start here for the function debounce push button. And here for demonstration, I want to show what it looks like without a debounce. So this is pretty much no debounce because I have a 0 here. And the function it calls is debounce here. So this is automatic. And remember, in main, or not main, but polling routine, this one right here, this is always looping right here. This is always looping, so it's always checking. So where was I at? Button counter. So so as that's running is and also here the system tick, it's always incrementing the ticks for all the functions that I registered. It's incrementing the timer tick in that function. So again, so if we go back here and I read the button saying it's pressed, I call this debounce, but there's 0 delay, so this automatically calls this right away. And then I start the blink blue LED, and I also put it to 0, so the blue LED will blink. This is calling directly, so it's going to toggle that pin for the blue LED on right away. Now let's go ahead and connect our development board, and give me a second here. I'm going to start up my oscilloscope. Alright, so you can see on the schematic I have the LEDs and I got the user wake up button. I am using the red LED and the blue LED. which is PD14, PD15, and the push button is on PA0. So, okay, so if you look at this development board, I have PD14 and PD15 connected to my oscilloscope. I have the push button PA0 connected also, and if you look here on my oscilloscope display, channel 1 yellow, channel 2 is a purple, and channel 3 is blue or teal or turquoise, teal. And so channel 1 is the push button, channel 2 would be the red LED, and channel 3 is the blue LED. Okay, as you can see, I have PD14 and PD15 connected to channel 2 and 3 of my oscilloscope. I have PA0, which is the push button, connected to channel 1 on the oscilloscope. So let's go ahead and program this board. So we will hit this run button. Alright, so it programmed and exit, and you can see here that when I had this polling routine that I wanted on power up to blink the green LED and blue LED, and you can see that the blue LED is blinking at 500 milliseconds on and 500 milliseconds off, and the amber LED is blinking at 100 milliseconds on and 100 milliseconds off. Alright, so if I push this push button and if we watch the oscilloscope, alright, I don't know if you saw it, but the red LED was able to pick up the push button right away on the interrupt, and then also the blue LED blinked, but you may not have seen it on the camera, but it did turn on and then went off. And if you can look on here on the oscilloscope, you can see that the push button went up high, and then there is some delay because it's polling, checking, but the red LED turned on right away, and at the same time the blue LED was called, so that was right away. But if you notice that the push button bounced here, so it's slowly dropping, and the red LED at some certain point, I think it was about 0.8 volts, is when it thinks it's a logic 0. So that's why the interrupt or the external interrupt was triggered, and when I read the button it was 0, so I turned off the LED. But then as this push button stops bouncing and it goes back up high and it's steady now, the push button or the red LED turns on again. Now because the red LED turned on, it's now signaling the blue LED, so that's why when I call blue LED it toggles, so that's why it turned off. But if I had debounced this correctly, the blue LED should have been staying high all the time. So that's the problem with a push button mechanical, that it will bounce, and the external interrupt, which is this red LED, picks up right away. Well, not right away, but you know, right when it drops down to about 0.8 volts, that's when it sees it as logic 0, so it turns off, and then when it goes back up high, turns back on. So it's doing this twice when it should only been turning on and staying on, and that's why there was 2 states of toggling this blue LED. So this is the first state that it toggled, and then this is the second. But in actuality, we didn't. If this didn't bounce, this blue LED would have stayed on. All right, so let's go ahead and we'll go back to this polling routine H file. And we'll comment out this no debounce, and then we're going to comment back in the normal debounce. So let's go back to button counter. So now oops, let me save this. Alright, so now I'm using, alright, so here, so normal debounce on the external interrupt. I'm calling push button here, but I'm waiting 20 milliseconds. So when the push button gets pressed, I have to see it on for 20 milliseconds before I call this. If at any time the push button goes low, I stop this debounce counter here. So once it stops, I never call this. So if it comes back up high, this timer will start again, and I have to wait 20 milliseconds. As long as it doesn't turn off, I then call this debounce. And then I also added for this blink to blue LED, but I added a timer for 1000 milliseconds, so 1 second. So this is calling the blink blue LED, and to toggle it. So once this push button is stable for 20 milliseconds, it calls this, and then I'm waiting for another 1000 milliseconds before I call the blink blue LED, which will toggle it. So let's go ahead, I'll just go ahead and compile this and then just run it. Alright, so I'm going to do the push button, and it's going to bounce, but you notice the red LED doesn't turn on because I'm waiting 20 milliseconds, and that 20 milliseconds is somewhere down over here. I only capture so much here, so let me change the division here, and let's see if I can capture the red LED. Oops, bounced there. So alright, you can see that the push button did bounce here, and I got 500 milliseconds division. So, and I'm waiting for, what did I say? I forget now. So the push button, 20 milliseconds. So let me change my division here. It's 1 millisecond. Oh, wait, 1, 2, 3, 4. Nope. Here. Alright, so let me try it again. Alright, so there you go. So you can see the push button went up, it bounced, and now it's stable. So the time between the second rise and to here is going to be 20 milliseconds. So since it never turned off in the 20 millisecond pass, now I turn on the red LED, and then at this point I start the timer for the blue LED, and that's going to be 1 second down the line. And yeah, I don't know if maybe I can capture it. So this 10, 20 milliseconds, 50, 100. So here we'll do it again. I'm gonna just press and hold the button because I need to hold it for 1 second after it finishes debouncing in order for the blue LED to turn on. So here we go, and there it goes. 1 second later, the blue LED to turn on. You can see on the oscilloscope, after the red LED turned on and stayed on, the blue LED turned on 1 second later. So that's how the debouncing works. So the red LED will not double trigger because I waited 20 milliseconds for this push button to settle, and that's when I trigger it, and then I wait 1 second for the blue LED to turn on. Now if I was to do this again and let go before the blue, right now the blue LED is on, so it's staying high. So if I press this and turn on the red LED, and so it doesn't look like there was a bounce here, so it turned on, and I released the button, and you can see that the red LED turned off at the same time. It was obvious polling routine delay. Alright, so that's that, and then let's go ahead and let's go back to polling routine H, and then we're gonna comment out normal debounce, and we're gonna do a button counter. So let me save this, go to button counter. So here my external interrupt, again I'm just reading the pin state, so when the button is pressed I'm going to call the debounce after 5 milliseconds. Actually this is shorter than the 20. I think I was doing something. Oh yeah, see here I had 5 milliseconds. I think it was trying something. I changed it to 20, and I think I uploaded the project to GitHub for 20, but 5 milliseconds will work. But then also I'm using button counter, so I enable that, and let's see. Okay, so I'm gonna call button debounce, or the debounce push button, in 5 milliseconds, as long as it doesn't turn off. And here I'm using button counter. So now I'm calling this function here, which is a button counter. Which is, oh, this is button count done. Sorry, not button counter. So this is button, I'm disabling this because I don't want to call, when I push the button, I don't want this to be called yet until 700 milliseconds later, which is here on the button release. So if I'm pushing it 1, 2, 3, and then I stop, it'll be button reset, and then that's when I want to do the button count done in 700 milliseconds, because at that time then I know that I'm done pushing the button. So when I call this, I disable this button count done so it doesn't call it again, because it is repeating. And then I'm doing this timer callback repetition start, and my value here, the button counter, which was right here, I'm incrementing the button count, and it started off at 0 here. So this button count, I'm calling blink blue LED, was 250 millisecond time between each blink, and I'm taking the button count times 2, because for it to blink the LED you gotta have an on state and an off state, so it takes two calls for it to blink the LED. So that's why I doubled the count. So if it was to blink the LED 3 times, I would need to if the button count was 3 and I need to blink the blue LED 3 times, I have to actually call this function 6 times. So, and then here I just clear the button count. So let's go ahead and program that. And at this point I don't need to have this oscilloscope on. You're probably hearing the fan noise, so I'm just going to turn this off. Alright, so here is the button count. So if I press the button 3 times, you'll see the red LED. It's going to debounce for that 5 milliseconds, and then it's going to call the blue LED to count it. Or I'm sorry, it's only going to count with the red LED. When I release for 700 milliseconds, then it's going to call that other function. Now I forget what it was called. Button count done. So it's going to blink the LED the number of times I had pressed the push button. So if I do it 3 times, 1, 2, 3, 700 milliseconds, it's going to blink it 3 times. If I do 2, it's going to do 2, and 3, 4, 5, 6, or was that 5 or 6? 4, 5, 6, 6 times. If I did 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Alright, so you can see that when I do the button count, I'm calling this timer repetition start and blinking the LED. And now this can be any function you want to call, and you can pass the button count here to that function, whatever it might be. Maybe it's sending a YORT message, and you want to see what the count is on a serial program. So again, you can, whatever you could think of, you can do. Alright, so that demonstrates how to do a button count. Alright, so yeah, you can see that this timer callback library could do a lot of things for you. Alright, so I'm done. What's that? Oh, let's see. Oh, alright, I have a bonus here. Change the blink rate. Oh, sorry. So I have to have both of these on. Alright, so I have to have both of these on in order for me to use change blink rate, because I need to count the number of times the button is pressed. Alright, so here my interrupt, I'm checking if the button's pressed, calling the debounce. It debounces, calling the button count done, incrementing the counter. That set LED just turns on the LED every time the push button is recognized after the debounce. Then button count. So I'm still blinking the blue LED the number of times. And then also I included a button count. If it's pressed once, I want to change the blink rate of the amber LED to 1 second. If it's 2, I want it 500 milliseconds, and 3 blinks or 3 button presses, change to 100. And then if I press the push button 4 times, I'm gonna blink it at 50 milliseconds, and that's gonna be pretty fast. And you may not see it very well in the camera. So let's go ahead and let's program this. Run it. Let's go back to here. So if I press it 1 time, it's going to change this amber LED at 1 second rate. So 1, release. Now you can see the amber LED blinking at a 1 second rate on and 1 second rate off. Now if I press the button 2 times, it's going to blink it at 500 milliseconds rate. Alright, so remember the green LED was at 500 milliseconds, so now the amber LED is matching the green one. Now if I press the button 3 times, it's going to blink at a 100 millisecond rate. 1, 2, 3. So not sure if you can see that on camera. Yeah, you can see it on camera. And then if I press it 4 times, I'm going to get a 50 millisecond rate. 1, 2, 3, 4. Alright, so if you've noticed that no matter what I'm doing, the green LED is always blinking at its same rate. It's never being interrupted. Even when I'm pressing the button, it's blinking the LED back, blue LED. The green LED keeps its steady rate. Now the timing is not going to be 100% 500 milliseconds because there's the polling routines and there's other functions that you may be calling. So there's going to be an extra time added. So, but on the oscilloscope, you may see an extra, who knows, I don't know, 50 microseconds added. But overall, it's still going to be pretty steady. So that's that example. Alright, let's see, polling routine H. Alright, so now let's comment out this. Oh, sorry, wrong one. Come out this one, this define. So now I have example 1. So let's see, here's example 1. Oh, let me save this. Alright, example 1. This will toggle the blue LED 10 times. So 5 on, 5 off, 500 milliseconds in between each call to blink the LED. So it just repeats this 10 times and then it stops. So let's go ahead and program this. So that's the callback repetition start. Okay, it's programmed. If you've seen the blue LED blinking, and blink it 5 times and then it just stops. And while that blue LED is blinking, the green and amber LED is blinking at its own rate. Alright, so let's go ahead and let's do example number 2. So this one, save that. Go to example. So this one is using structure to set up these parameters. So instead of calling a function like this and passing all these variables, on this one I'm actually creating a variable here using the timer callback structure. Alright, and then now I'm individually setting these parameters up, and then I call the timer callback register the structure. So here my callback is blink blue LED. My timer value is 500, so 500 milliseconds to call each time. The timer repeat is true. Timer enable is true. And then this one's repetition value 6, and I have to enable it. And then here I have a callback number 2. Oh, this is what's cool is the secondary callback. And so I'm going to set the red LED, and I have to enable that. So what's going to happen here is I'm blinking the blue LED or calling the blink blue LED 6 times. So it's going to be on, off, on, off, on, off. So actually you'll see that blue LED turn on 3 times, and then it's going to be on off state. After it's done, this repetition will stop, and it'll stop the timer. But at the last one final call, it's going to call this set red LED, and timer's disabled after that. But so let's go ahead, let's program that. Oh, I have a error here. Oh, I did some changes and I have to fix that in my library. I'll have to load that to GitHub. But so here I have to pass the instance of the timer. Let's see if that works. Yeah. So like timer structure here, I have the timer instance. Originally I only had added this right here, but now I'm making sure that these variables are added to this timer instance, which happens to be this one right here when I passed it here. Alright, so let's go ahead and run that. So there you see I have a bug, and kind of show you how I figured it out. Alright, so here, sorry I wasn't even looking at the board, but let me reset it. And again, it's going to call that blink blue LED 6 times. So you'll see the blue LED turn on and off 3 times. And then the last secondary call is going to turn on the red LED. So here we go. 1, 2, 3, and now it does the secondary callback, which was to turn on the red LED. Alright, so that was example 2. Let's do example 3. Let me save that. Alright, so example 3, let's see. Alright, I renamed this. So that's another bug. So when I made this project and I finished it, I then started making some changes to the TimerCallback.c file. So what is this? I think this is timeout. Let's see if that works. So yeah. Alright, let's see if this compiles. So basically here I'm calling blink blue LED at a rate of 333 milliseconds, which is an odd number, but you want it to blink for 3.1 seconds. So if you want to get down to the now if you want to be able to be a little bit precise, to blink up to 3.1 seconds instead of using a repetition, because you would have to do some calculations based off this 333 millisecond rate. So it's just easier to have a timeout. So let's go ahead and program that. This example was blink blue LED, 333 milliseconds in between each call, up to 3.1 seconds. And we don't know how many, well, you would have to calculate it to find out if you wanted to have the LED off, you would have to adjust it, and maybe it's at 3.2 milliseconds to have it call an extra time. So actually it's probably be 340 or 3,433 milliseconds in order for it to make another call to blink blue LED, so that way the blue LED is turned off. Alright, so that's all of the examples. Alright, so as you can see, this timer callback library does a lot of things. Does more than just calling back a function after a given time. It can do a timeout after a certain time. It can do a repetition, and does a button debouncing. It can do a button count. It does a lot of things. So it's all up to your imagination and what you can do with it. So if you like this video, please give me a thumbs up, and I'll see you in the next one.